So today we are looking at another mathematical induction problem, and it says that use the method of mathematical induction to prove that if n is a positive integer, prove that. This is what we are asked to prove. So now let's start. Now let's assume that everything in this is equals to let everything in that be so. When n equals to 1 from the left hand side, from the left hand side, what you have is 1, over 24. So let's also try for the right hand side. For the right hand side, what you have is 1, 1. We have seen that let n be 1. That will be 3. 5 into 1 plus 3. So what you still have at the end of the day there is 1 over 24. So we can see that the formula is valid for n equals to 1. So let's assume let n be equals to k. So that means we're going to change everything here to our k. So copy everything here. So change this to k and change this to k. Change this to k. So let's assume that. So let's term this 1. So for n equals to k plus 1. So we are now moving a step further for the n plus k plus 1 term. So now that means I have to clean this. So now that will be the next term after our k. This one we have to change to k. So we are dealing with k. So now, so what we have here is 5 into k plus 1. So that's the term we are dealing with. Minus 2. Then 5 into k plus 1 plus 3. So remember, from 1, so everything here, everything here stands for you. So don't forget that everything from here, so we can rewrite this as k into 3 to 5k plus 3. Don't forget that. So plus, Now this one, let me simplify it. So we have 1, that will be 5k plus 3. Then the other one will be 5k plus 8. 5k plus 8. So this is what we have for that. Simplifying this gives us this. So what we need to do is to find the LCM. The LCM will be 3 into 5k plus 3, bracket closed, 5k plus 8. So we have k into 5k plus 8 plus 3 plus 3. So that will be for that. So simplify this further. So this gives us 5k squared plus 8k plus 3. So you don't need to open the denominator, just leave it as it is. 5k plus 3 5k plus 8. So we have that. So let's see whether we can still simplify this. Looking for the factors of that will give us 5k all squared plus 5k plus 3k plus 3, and 3 into 5k plus 3, then 5k plus 8, bracket closed. So you have 5k into k plus 1 plus 3 into k plus 1, then 3 into 5k plus 3, 5k plus 8. So you can still work on this. So we have 5k plus 3, bracket close, then k plus 1, then 3 into bracket 5k plus 3, then 5k plus 8. So this man, we cancel out this. We cancel out this one. So what we have at the end of the day there is k plus 1. Let me put it in parentheses. Into 3, 5k plus 8. Now, once you've gotten up to this level, there's nothing you can do again. Just for you to look at how can I simplify this so that it will look similar to the first. It will look similar to this. It will look similar to this. So that's what we're going to do now. So let me show you what I normally do to show whether I'm really on track or not. So k plus 1, 3, bracket opened, 5. So I will now put k plus 1. So 5 times k will give us 5k plus 5 times 1, that will give me 5. I still need 3 to be complete, to make it complete, so I'll add plus 3 to this, then close the bracket. Now let my k plus 1 be equals to n. So I will now put anywhere I see k plus 1, I will change it to n. So we now have n 3. So anywhere I see 5, okay, 5 k plus 1 will change to n plus 3, bracket close. So if you look at this, does it look similar to the first one? It is. So that shows that the formula is valid for k plus 1. So the proposition is valid for k plus 1 time. So the formula is valid. So that's what we have been able to show. So we have been able to show that this formula is valid for all values of n. N is a positive integer, natural numbers. So all positive integers. So thank you for watching. So don't forget to subscribe, like this video. Thank you for watching. So this is the whole solution.